Let's understand this question. Two bodies of equal masses are placed at heights h and 2h. Find the ratio of their gravitational potential energies. So we can do it with intuition. The potential energy depends on this formula, mg delta h or h. So we can denote by this. So if the masses are same, this is constant, we can say the potential energy will be directly proportional to their height. Whenever we get the proportionality sign like this, we can always say u1 by u2, the ratio of their potential energy will be the same ratio as their height. So that is by intuition. But mathematically, if we want to show, how we can show, as the masses are equal, potential energy divided by potential energy 2, mgh1 and mgh2, right? So this is 2h at the height of 2h. This is mass is at the height of h only. So this masses being equal will cancel out. G is also will cancel out. And we'll get the simple ratio of h1 by h2, which is h by 2h, right? So this height is 2h. So we will get 1 by 2 or 1 ratio 2. So that is what the we were intuitively also doing. So we can directly say it is 1 ratio 2. Okay, let's do the next question. It is directly formula mg delta h. So the gravitational potential energy is for m, h is given and g is also given. So just need to calculate this. So you can do it by yourself. Let's go to the next question. The box of weight this much has a gravitational potential energy stored in it equal to this. So potential energy is given, the weight is also given. Okay, find the height of the box above the ground. So we know potential energy equal to this, and this is given to us this much. So we will equate this like this. We will put the mass and kilogram force we are changing into the Newton. So we are multiplying it by 9.8 because they asked us to, to put value, take G value of G as 9.8. And from this we can calculate H, and H we can calculate as 10 meter. So the height is 10 meter. Okay, let's go for the next question. A body of mass F5 kg falls from a height of 10 meter. How much energy does it possess at any instant? Okay, so at any instant, if there is no friction, only gravity is working on it, then at any instant its mechanical energy will remain same. So it will have the energy of 500 joules. Whatever the potential energy we can calculate by mg delta h, it will m is this multiplied by this 10, 50, and then again multiplied by 10, 500 joules, and it will remain same. Let's go next. So this is again a simple question. You can do it by yourself. Calculate height through which a body of mass this much should be lifted if the energy spent doing so is at this much. So in this case, the potential energy is given to us, and we have to calculate H. So you can do it. We have done a similar question as before. So let's do next question. A boy weighing 25 kilogram force climbs up from the first floor at height 3 meter above the ground to the third floor at height of 9 meter. So whenever we are the different heights are given, you have to see how much displacement net is. So net displacement is 6 only, 6 meter, right? Because we are going from 3 meter to 6 meter, 9 meter, sorry. So 9 meter is here, 3 meter is here. So in between what will be 6 meter. So 3 plus 6 is 9. So that's why this is what they are not given directly height. They have want us to calculate that. So we can calculate 6 meter. What will be the increase in its gravitational potential energy? So increase in potential energy will be the work done by us against the gravity, which we can calculate mg delta h. So that will be 25 into 10 into 6, that is 1500 joules. Also, if you have any time confused, just calculate work done by gravity, okay, and reverse its sign. So that will be, this formula will save you in any case of confusion. That will be changing potential energy. So now if I draw the diagram, so this is 25 kilogram force or 250. Newton, and we are raising it up 6 meter. 9 minus 3 is 6. So the work done by gravity will be negative, but it will be just multiplication of this 25 into 250 into 6, that will be 1500 joules. If you reverse the sign, we will get minus work done by gravity will be negative because gravity is acting downwards and displacement is happening in the upward direction. And now if you use this formula, you have to do negative of work done of gravity. This will cancel out. So the change in potential energy is positive. The potential energy is getting increased. So this formula can help you in case of you are confused like which force to take. Okay, let's go next. Question number 7. A vessel containing 50 kg of water is placed at the height of 15 meter. Assuming the gravitational potential energy at ground to be zero, what will be the gravitational potential energy of water in the vessel? So this is just a mg delta h formula application. You can do it by yourself. Eighth also is very easy, but let's read it. A man of mass 50 kg climbs up a ladder of height 10 meter. Calculate the work done by the man. So work done will be against the 50 kg F force, and the height is also given, so you can calculate it. And the second, they have an increase in potential energy. So whatever work he has done against his force, okay, or you can calculate work done by gravity and just flip it sign, then you will get it, the increase in potential energy or change in potential energy. Okay. Let's go to question number 9. A block whose weight is 100 Newton, not 200 Newton, it's 100 Newton, is pulled up a slope of length 5 meter by means of a constant force of 100 Newton. Okay, as illustrated in this figure. What is the work done by the force in moving the block A 5 meter along the slope? So understand, while calculating the work done, we just need to see whether force and displacement has some angle or not. So this is the point I'm showing the box. So the force is this way and we are pulling like in that same direction. Then we, they are just saying the pulled up by up a slope, so we are pushing it, pulling it like this, so we are applying 100 Newton force, so it'll be just 500 joules, just multiplication of that because they are in the same direction. Now what the next part is, by how much has the potential energy of the block has increased? So for calculating the potential energy, we also see these kind of questions. That's why important to understand, like the change in potential energy will be always work done by gravity with the negative sign. Flip that sign, you will get the change in potential energy. Okay, and for potential energy we only see the height, and height is given here is 3. We don't have to take care of which path this body is coming. We just have to take the 3 meter height. So what is the potential energy here? We just have to calculate mgh, and we will get the answer. Mg delta h is equal to 100. Okay, 100 Newton force, because that weight of the body is also was also 100 Newton. Okay, so that's why 100 into 3, 300 joules. So this much potential energy is being increased. Okay, what is the next part? By how much the percentage of the block has increased? Account for the difference in work done by the force and an increase in potential energy of the block. Okay, so we have done this much work done, 500 joules, but only the potential energy is increased by 300 joules. So now they are asking like, oh, where that 200 joules remaining went. So that may be gone into the friction, sound, other kind of what you say, dissipation of energy. There are many means. So it has gone maybe there. So that is what the answer is. The total work done on body was 500 joules, which 300 joules is used to increase its potential energy. Rest of its 200 joules may be used in other forms of energy or heat, sound, etc. Now also in this question, they have not told that we have pulled it with a constant speed. So it might have also gone into the increasing its kinetic energy, as they are not mentioned that block is pulled with a constant speed. But I think they wrongly framed this question. Otherwise they would have showed that we are pulling it with the constant speed. Then this kinetic energy will not come into the question because we are not changing the speed of the box. Okay. Let's do the 10th question. Find the kinetic energy of a body of mass 1 kg moving with a uniform velocity, and this much, just a formula. the kinetic energy half mv square we need to put, and we need to get the answer.